So value A, known as the indefinite integral of f of x from A to B, is written in that particular form. Again, it is the area underneath the shaded region. That's known as the fundamental theorem of calculus when you actually go through the process to figure out what exactly is that definite integral on that particular bounded between A and B. Okay? What we're going to do is we're going to take a look and we're going to evaluate those following integrals using the area interpretation of this particular function that's given to us over here. Okay? Now, we are talking about area underneath the curve. These are some of your easier types of problems when dealing with the definite integral, okay? Because area, you can think old school area type of problems, all right? All right, so this is basically asking you to evaluate from 0 to 3 for the function that we have here, okay? So, our function is asking us what is the area underneath this curve from 0 to 3. So basically it's asking us what is the area underneath this curve. Now when we take a look at this, dang, this looks just like what shape? A trapezoid. So to find the area underneath the curve or to evaluate the integral from 0 to 3 for this particular function, we just need to find the area of that trapezoid. Okay? Does anybody remember the area of the trapezoid? 1/2 parenthesis plus base 2.
Isn't that a pentagon?
No, it's a quad. It's a 1, 2, 3, 4.
That's two bases.
It does. Ooh, it does have 2 bases. Ooh, good point. Good point. Well, one of them is a
Okay.
2 trapezoids actually. Does everybody see that? I mean, you could split it a different way. You could split it here and see 2 trapezoids that way. Either way, doesn't matter. Okay. Got it. We still need a trapezoid formula, right? We're missing something though. You got the 2 bases, you got half, but there's something at the height. You gotta multiply by the height. So we got 2 trapezoids here. Let's call this top one 1, bottom one 2. So it's gonna be 1/2. What's the height of that trapezoid?
3. 2.
It's gonna be 2. And then our 2 bases are 1 and 2.5. Kind of hard to tell. I guess maybe we should split the other way so we can see a better idea. Okay. Well, let's change this. It's cool. Change it up.
Is this an example or are we just finding it?
It's an example that will go along with your notes. So let's see. If we split it here, is that better?
Yeah. So bases are 1 and 3.
All right. Our bases are 1 and 3, and our height is what?
1.
3.
1.
Wait, what are your bases?
3. 1 and 3 and height is 1.
Height is 1.
What are we looking at?
Because if you look, if you remember anything about a trapezoid, your bases are the 2 parallel sides. So that's 1 unit and 3 units, and then your height is the distance between those 2 bases.
I still remember geometry.
As you should. You should never forget anything that you learn. So there you go. Trapezoid 1. So what's 3 plus 1?
4.
Half of that is
2.
2. So the area of trapezoid 1 is 2 units squared. Now this other trapezoid, or is it a trapezoid or, yeah, trapezoid. What's the base?
1,
1 and 2, and the height is
2. Oh, my bad.
3. So for trapezoid 2, height's 3, bases, so 4.5. So the area of from 0 to 3 of the function is the what?
Sum.
The sum. So our answer for A is 6.5. These are the easier problems. They get a little more.
super easy.
How do we do that?
How do you do it that way? these you would have to do without, like, with using a graph, okay? They would give you a graph. Otherwise, f of x could be any type
They
of
would
function
give
that
us a
we've ever
function
used.
and then we plug in b and a, right?
Mhm. But we'll get to that in a second. So I'm
So is
gonna
this like,
use
is this is this like the non-calculator?
all these ones that we'll do in
Is
our
this how it would test this?
But usually the f of x will be this curve. Let me look at that.
From
This
3
is
to
actually-
7, we're talking about this for B. What does that look like to you guys?
Do a triangle.
Looks like.
You can do a cylinder and then
Cylinder?
Wait.
Looks
Those
like
are
two
triangles. Two rectangles
Looks
and a
like two
triangle.
rectangles, a bigger rectangle
So are you saying like here
from
Yeah.
4 to, no, 4 to
and
7.
here? Or you wanna cut it that way?
Yeah,
Oh, wait.
that's what I was thinking.
First that's not.
One triangle, trapezoid, and a big rectangle.
Not the, not
Do you see what I mean? From 4 to 7.
From 4 to 7 right here,
the.
and there. I mean, honestly, you could cut it any way that you wanted to. Go ahead, you guys. Cut it how you want to and find me my area. Do it right now. Okay? And then I'll cut it the way that I would see, what I would cut it for myself personally, and then we'll go from there. Okay? So you guys go ahead and do that. And find the area from 3 to 7. But if you cut it this way, again, you have some whole numbers. But the thing is that we are below the x-axis, which means what? What do you think?
Yeah, they absolutely.
Well, now when we're trying to find your area underneath this curve, it's still going to end up being negative. So in this case, the area here is going to be a negative 3/2 for that first region. For the second region, that's a what? Because it's just a what? Just a rectangle base times height, so 1 times -3, which is -3. Region 3 is a trapezoid with a height of 1, and my two bases are -2 and -3. When I add those together, it gives me a -5, so this is a -5/2. And then lastly, the last one is a -2. So when I add these all up together, it is what?
Negative 11.
-11? Whoa. Okay, so -3/2 and -5/2 make a -8/2, which is -4. -5 is a -9.
So when is it negative, but we don't like the answer is negative?
When you're talking about like distance travel. We'll get to that. Okay, let's speed this up just a tad bit. Looking, we're good? Okay, looking at C, from 2 to 4, we have basically from here to here. So we have 2 regions. And why do you think it's 0?
Positive, negative.
Because one's a positive, one's a negative, and they both happen to be what? The same. So yes, for C, this one is going to end up being 0. And then for the last one, from 0 to 7, we basically take A plus B. Because if you think about it, we already found the area from 0 to 3. We found the area from 3 to 7. So basically, we take the area of part A and we add it to the area of part B. And what do we come up with the area of part A? Let's just delete it.
6.5.
And what was the area for B? So then it's actually going to end up being a, careful, 2.5. Questions? Yes?
Do they have to put units where?
Just using proper notation, since it's talking about area. When we actually have regular functions, we would just leave it as whatever the number is.
Oh, this one we just did 2 triangles.
For C, it's basically 2 triangles that are basically the same dimensions. One's a positive area, one's a negative area, so that's where we got 0 from for part C. And then for part D, we took the 2 answers from A and B and added them together. All heads, remember? This also could be done this way, without a graph. So they're still talking about a general function. They say that if the integral from 1 to 3 of a function is 2, and the integral from 1 to 6 of a function of the same function is -3, then what is the integral from 3 to 6 of that function? You have to what?
Subtract -3.
You would have to subtract it, because if you think about this function, right? So from 1 to 3, whatever the function is, it really doesn't matter. You basically have +2. And then from 1 to 6, you basically have a -3, whatever the function is, okay? You have a -3. So you're really looking for this area right here, which is the difference between the two. So we take from 1 to 6, and we subtract it from 1 to 3, we will get the area from 3 to 6, which is,
Do you subtract the one that comes first, the one that's smaller?
the bigger one,
Yeah.
the bigger area from the smaller area, yep.
Very small.
Or the bigger range, I guess, from the smaller. For the next one, from 0 to 2, from 4 to 6, from 0 to 6. What do you guys think?
Yeah.
How would I find from 2 to 4?
Oh, you add 5. Oh.
Alright.
Subtract 5 and make it 2.
You have 6 to 0.
Take
You have
seven.
6 to 0.
You subtract 0 to 2 right
You know this whole area right here is 7.
Take 7. You subtract the other 2.
And you subtract the other 2, because you have from 0 to 2, which is 5, and you have from 6 to 4, which is a -2. So you would subtract them from the whole thing to find the area that you're looking from 2 to 4. So it will be questions on using this. Now, I'm just making up some general curves. These probably are something more along the lines of a trapezoid or something like that, but you just need the general idea. Yes,
Using the first one.
okay. Now let's take a look at it again.
Do it like a square.
Yeah, that's a good way to think. Think of it like a square. So you basically have from 1 to 6, and then from 1 to 3, okay? So you know from 1 to 3 is 2, and then you know from 1 to 6 is a -3. You're trying to figure out what is this area right in here, okay? So basically, you know the whole area, we have this piece, we're trying to find this piece, so we're gonna take the whole area and subtract this piece here. Yeah, think like that. 2 plus 1 is gonna give you a -3. So it's gonna have to be a -5.
Wouldn't that actually
You know-
be under the curve?
I mean, at some point in time, it is gonna cross under beneath in order for it to be a negative, but I mean,
You know it's hard math when the whole is less than the sum of its parts.
Yeah.
Do you know that?
question, David.
You just
That was
glue the pieces.
The joke.
You glue that
Alright.
with the pieces.
So. Okay, this is basically another way to represent this curve. You know that the area from 1 to 3, this is 2 units right there, okay? Alright, now the total area of this region, that blue shaded region, and this red shaded region together, okay? So red plus orange has to equal what? Okay? Now we already know that the area is 2 for the orange part. We just need to know what's the area for the red part, so that when we add them together, it gives us a -3. So we subtract 2 from both sides, we find out that the red region.
I love the curve.
Don't get there.
It's just another variable.
Pretty much. Y'all like him last year. That's what put that out there. Y'all really there. Y'all like, I don't see it. Like, okay, let me try to draw it over. Alright, so good? Cool. Let's take a look at these. Let's take a look at these. These are some of the more harder ones as you get through the,
Are we on
I
whiteboard
always
yet?
forgot the rule for like more fun.
No, I thought we were gonna do this one faster, but we probably won't get to the whiteboard today, so it doesn't matter. Thanks, Dan.
Oh, how to do it?
Well, it's just, alright, one of your properties for your definite integrals comes in the very first one, in this very first example, so given that the integral from -1 to 1 of your function equals -4, we have to determine the value of its opposite from 1 to -1 of f of x dx. Does anybody remember?
Yeah, you make it.
You switch
Fine.
Exactly, all you do is you just switch the signs. So this is basically the same thing as saying a negative. That's all that is. So since we know that from -1 to 1 of the function is -4, this becomes a -4, which is indeed a positive 4. That is one of your rules, one of your properties of definite integrals. Okay? So you have the exact opposite. If you have just the bound switch, then it's just the opposite of that. Okay? The next one, since they're being added, you know you could do what?
You
Two?
can substitute
Okay, guys.
that for x for negative.
Add it to the, no.
What is it? Don't you,
Add,
add it out?
Mm-hmm.
I eat it out.
Don't do that.
Take it out? I forget where you.
Well, no,
Fine.
no.
We could do something.
You feel like you do something
You
too?
raise-
Multiply it
If you raise the graph,
It's either
so that
B or
just
C
adds
multiplied.
two
You multiply it?
per.
You add it to
Think.
the
Go ahead.
boundary.
You add it to the bounds?
'Cause it's-
Not
Okay.
quite. Your bounds are related to your x's, right?
Mm-hmm.
But when you add a
You
number to
remember-
the original function, what does that mean?
It should
Your
Left.
It shifts up.
So it's
So basically,
Plus.
you have this curve that from -1 to 1
Oh, it's
is originally like this, okay? But now it's been shifted up 2 units, okay? So now it looks like
Oh.
this,
all the way down to,
okay? And so basically, since it's been shifted up to, your original area of -4 now has an additional
Oh, yeah.
So you
extra
add
space
this
underneath it.
square.
2 by 2.
so you
2
add
by.
the 2 times
square.
the range.
2 times the range, which is basically 2 times
2.
2. So basically, you have to add in this additional area underneath, which is a measurement of 4, to your -4 units,
So then you get 0.
which is just 0.
Wait, isn't it the other way around?
Yeah, this one should have been like down here, and then I should have shifted it up
Wait, I
this
thought
way.
it'd be like, this is the curve, right?
Mhm.
And then you have the, I thought it'd be like, that goes in the middle and the curve.
No, you think
Because
think you're thinking something different.
affects the x.
this,
It's not like that?
the only time it'll affect the x is if it was in the inside. That's when it'll affect the x. Over here, what do you think we can do?
Multiply. You need to be constant.
It's a constant, so you can pull it out. So you basically just have -4 times 2, which is -8. So that rule still applies there. And the last one, it says find k such that
Also, the constant. Take out K.
you can take out a k, you can plug it in. So you'll basically have k times a -4 equals 7. So k would equal a -7/4.